Okay.
Yes, sir.
Okay. So today we are going to talk about C programming, and we will be focusing more on those aspects which are very important for embedded C or writing C programs for embedded systems. Okay. Uh, I have already started uploading some videos related to embedded C in my YouTube channel, and I believe most of you are following that. If not, then please follow it, because in the class it will not be possible to cover all the details, because there are so many things to cover, right? And it is not possible to teach C, whole C, okay, in the lectures. Okay, for that you can go to this playlist. I will be uploading. I'm still working on the playlist. Okay, so till now I have uploaded 4 videos, and I will keep uploading more videos related to embedded C. But apart from that, there are many aspects which are very important for the course. I'll discuss them here, and of course I will show some of the uh, major features of C and major uh, features of embedded C, precisely speaking, during the class. Okay, and I will show you how to simulate them, and how to check whether the results are correct or not. Okay, so we'll be here in this part. We'll be more focused on program writing skills, okay, in C. Okay, first of all, we'll be going to cover how to write a simple program, modify the program and its output, understanding the main function, outputting informations in printf function, improving your program readability by using comments. Do uh, write comments when you are writing a program, until unless you are very thorough with your coding techniques. But this is what mostly this is the section which most of the engineers lack, and I believe this is the most important feature of any programmer. Do you know why? Anyone? Why putting comments is most important feature or any parameter of any programming?
When we come back to our code, we can know what it did.
Look, this is the basic what to say, uh, wrong idea about writing a code. You are not writing your code for your own knowledge or something. Remember, when you are going to write a code, of course, when you will be working in a company, you are not writing a code for yourself. You will be writing your code for your team, okay, or for others. So this mentality should change, that whenever we come back and we go through the lines, we should understand what the program is going to do. You should remember, you are writing a code for someone who is not present when you are writing the program. You are writing for someone who is not with you when you are when he is reading the code. Might be possible you left the company and you left a big program, and that company, if suppose tomorrow want to modify something, it is not possible to go through 1,000 line code and change some parameters in the 1,000 line code or 5,000 line code. In that case, comments are very essential to help others to modify the code and all. So remember, when you will be working in a company or when you will be working in a team, the most important aspect of programming is putting comments. And many a times, even if you start writing your program by just putting comments and then after that writing the program, that okay, I am expecting this, can I write the program for that line? You can call it pseudo coding and all. Okay, so I believe commenting is very important when you are working in a team. Of course, apart from that, the the very basic things like defining data types, what the data types are, how much space they are occupying, what can be put in that data type and all. Okay, so these are the things which we should know. For example, int. Let me just
Sir, you are not
briefly.
Sir,
sharing
you are
your
not
screen.
presenting.
So
I'm
you are
not.
not presenting.
Okay, just a second. It's not presenting. Okay, now is it presenting the screen?
Yes, sir.
Yes, sir.
Okay, for example, int. Many of you might have written programs in C or any other language, and most of the time you use the variable int. Can you tell me what can be the maximum size of the number that you can load in int? Just let me go through someone. Yes. Can you tell me what can be the maximum size of number which can be loaded into int? Hmm? For example, most of the time we just write int a equal to 50 or something like that, right? But can you tell me what is the maximum size of the number which can be loaded into a?
So 10 की power 9.
10 to the power 9. Anyone else? Anyone else? Anyone else? Anyone with
Sir,
any other answer?
2174 something.
2174 something. Okay. Anyone else? Anyone else who has a different opinion about it? Harshita, can you tell me what can be the maximum size of the number that can enter into int? So now you see here, though it is the very basic concept, and most of the time we think that okay, it is so common that we don't have to look into that, right? Right or not? Because now you are using a variable of any data type, int, float, or double, but in real term you don't know what can be the maximum number, and might be possible you are entering something into the int and actually something else is getting entered into the int. What does that mean? It means, for example, if I am entering 50, of course a will get 50, right? And if suppose this number is beyond the size of int, what will happen? Okay, char or any other number, char. Okay, char, can you tell me what is the maximum size of char? 1 byte, right? So but in that 1 byte, what is the maximum number that I can load? These are the things which we take too casually. For example, someone was telling 2174. Can you tell me why you are coming to that 21 something something? Hmm?
बस याद है सर.
Okay, many in this lecture itself or in this course, I told you int is dependent on whom? Int is dependent on?
Sir, how much bit of
Systems word
processor?
size.
Yeah, the number of bits
The
in the
processor.
processor, right? Now I was asking you for last 2 or 3 minutes, how many actually of you actually tried to correlate this to
So 2 to the power 32, right?
2 to the power 32, right? So now can you tell me what is the size? It is 4 GB almost, 4 GB, but 4 GB is not 4 into 10 to the power 9 or so. It is for example, when we say 1 kilobyte, 1 KB is not 1000, it is not 1000. Okay, it is 1024, that is 2 to the power 10, right? So similarly here it is not just 4. So when you are giving this number, not 2174 something, you are talking about signed numbers. Okay, so you are assuming that int is signed. In that case, there will be a number 21 something something something, and then 0 minus 21 something something something, 0 to plus 21 something something something. That's the range of int. So here 4 GB is, if you are going for this, if it is unsigned, it will be 0 to 4 something something, which is 10 to the power 9. So these are the important things. So please do remember, things may look very casual or very obvious, but they are not very obvious when working in an embedded system, because in embedded system everything is dependent on the size of registers, the size of the variable, how they are allocated. Told you before also, aligned, unaligned, numbers and all. Okay, so there are so many things to keep in mind. It's not just write a code. Okay, Similarly, how to modify a data type from one data type to another data type. In that, I have uploaded a video in my YouTube channel. What is the term called, technical term called, to change the data type? For example, I declare a variable int a equal to 50. Okay, assume. And now int a equal to 50, int b is equal to 100, and then float c, right? And then I say c equal to a plus b. Is it correct or wrong? Is it right or wrong? Will I get a number here? For example, if I write print f, okay, double quotes, value of c is, okay, percentage I, and then slash n, okay, double quotes, comma c. What will be the value in the console? Or will it give me an error that no, you cannot do this particular execute, or you cannot write something like this, because float c is a float data type and you are trying to add two integer and put it into a float variable. It is not allowed in C. How many of you think this is allowed or not?
So it is allowed typecasting.
It
Yeah,
is allowed.
Implicit
the term is called typecasting, right? Typecasting, and it is allowed. But if I go in another way, or if I just change the type of the data type, okay? So if suppose there was a float 50.3, okay, and float b equal to 100.01, okay, and now c is int, is it allowed now? Now can I print c directly, or do this particular, execute this line c equal to this? Is it allowed?
I guess it will take the integer part of the a plus b.
Uddhav, what is your
Yes,
opinion?
sir.
Will this program run or it will throw an error?
Sir, it will throw the error.
Why?
So because the answer should be it will contain some decimal point, and in the int it is not allowed.
Okay, please do watch my videos, okay, in C, because I'm trying to cover many books and very many websites, and from all of them, I'm trying to make some videos, okay. So remember, float is have higher precedence than int. Okay, precedence means it has got bigger size in the, it is given bigger priority, you can say. So you cannot come downward without, what to say, typecasting. In this case, if you want to put the value of a plus b in C, which is an integer, then you will have to typecast this, like you said earlier. So you will have to write that, convert this a into integer first, similarly convert this b into integer first, and then add them and throw or store the result in C. So now, like you said, typecasting, you know the concept of typecasting, but right way to use it, because most of the time we don't use such expressions. For example, int a plus int b, sorry, bracket will be here, okay. So int b, so this kind of stuff we don't do in generally in our classrooms and in courses. But most of the time it is very important when you are handling such variables in embedded system, because I told you in the past also that float variable, a float type, is managed by FPU, float, right? So floating units are specially dedicated for float variables. So in that time, if you mismanage this kind of things in C programming, they will keep on throwing errors. So please keep an eye on this kind of basic fundamentals, which look very obvious, but they are not that obvious in embedded system. We have to keep an eye on all these factors. Okay, so we have to be more cautious when we are writing a program for embedded system. Okay, now in C program there is something called preprocessor, and they are always represented by, or they always preside by one hash. Okay, so hash will represent that the value after that hash is a preprocessor. How many of you know what are the things related to preprocessor? What are the things which are very important to keep in mind in preprocessor? Preprocessor, when you will use preprocessor in your program, like define. Most of you might have used define. Suppose pi, okay, 3.14. You might sorry, no semicolons. I think I'm not sure about that. Okay, so no, there will not be any semicolon, I believe. So you might have used this. What is the use of preprocessor, or what are the special things that you recall about preprocessors? Anyone?
It is processed at the time of compiling.
Okay, these are the things. Yeah, these are the values, or these are the instructions which are processed even before the main. Understood? So these are defined before the main starts. So these are pre-processed. Okay, so we will cover these parts. Okay, then compiler, of course, compiler expands the source code into assembly code and all. We always call cross compiler when you have to convert C files into Java, or Java to some other Python or something. There are cross compilers also available. Okay, then we have assemblers, which converts assembly code to object code. So please follow this. Okay, first of all, the preprocessor will run. Then after that, the compiler part will run, in which the program that you write in C will be converted to assembly code. Then assembler will come to part where the assembler will convert that assembly language into its equivalent object code. Then after that, there will be linkers. Linker are, like I said, link register. Okay, there is a different thing, but linkers are generally used to combine all different header files and their definitions. And wherever you require them, these are the things which actually connect all the objects together. Okay, so it is not that you just write a C program and it is just compiled and everything is okay. No, there are so many different files which are generated in the background. I will show you that also. Loader, okay, this is the part which actually loads the code, because most of the part in C programming, when you do in computer science related subjects, they stop here itself. But then we come to the role where we talk about the loaders also, which loads the code. Which code? The binary code, bin code, or the exe code into the CPU, and then executes them. Because here we have to be very careful about the CPU, in which processor you are going to load that program. Because CPU to CPU, the variable size may change, the functions may change, maybe the header files may change, and so on. Okay, so loader is very important when it is used to load the program. So this is the sequence which is followed when we generally write a C program. So first of all, we write a C program, which is the source code. Then it is expanded. Then it is assembled. Then object codes are generated. Then exe codes are generated, and then loader is load that value or code into the CPU. Okay, so during this particular part, you can see source code, first preprocessor will run, then the compiler, then assembler, then linkers, and then loaders. Okay. Apart from that, whenever you write a C program, okay, we generally write a C program, at the background, there are so many other files which are generated, like here the proj is the name of project. Okay. So suppose you created a project proj.c. Then in that C file, when you compile it, it will generate .i file, .s file, .o file, and .exe file. Okay, let me just briefly show you this. Okay, here. For example, here we have the test code. Even when we write a simple program, for example, this is the program hello world dot. Okay, so this is the workspace, and let the workspace get loaded. Okay, I believe you can see this code, right? So here we have the workspace, then we have the project, and there are so many files in that project. So suppose we are talking about any of these files. So these are .c files which we write in the compiler. We wrote this file, and then what we do, we build it, right? So let me just go to this and build a program. We build the program, and during the build, you can see there are some instructions like test getChar.0. So test getChar is my C file name also. Similarly, there is one object file created, and let us go and see what other files are generated in the background, because these are all important. And when you write a program, you should keep an eye on all these things also. For example, this is the folder where we have the project. So here you can see there is one depend file is generated, layout file is generated. So main.c is our, okay, just a second. So main.c is our program, right? Or test getChar.c is our program. Integer test_integer.c is our program. Apart from that, .depend and .layout has been generated by the compiler itself. Then there is a bin file under which you have debug. You see here .exe file is there. Okay, let's go back and see in the object files. So in the object you have debug and you have .o, .object file. So now the question is, what are there in these files and all? It is not, I'm not going to cover all those aspects here, but because I was just covering this part, I wanted to show you that, okay, there are many other files which are generated in the background, and it depends from compiler to compiler. They may generate some other files also, but this is what a simple C program actually is compiled, and then we load that particular bin file into the CPU. Okay, we know about stack, but we might not be knowing about the heap. How many of you know about heap? You might have heard about stack memory, but how many of you know about heap? Heap, H-E-A-P. Anyone who knows about heap, or who has worked in C program and knows what is heap and how it is managed? If not, then please go through the heap, because there are so many beautiful lectures which are only to define how the heap actually works and how the stack actually works. We already talked about stacks, right? Stack is a memory which is allotted in the memory, okay, main memory, where whenever we are using any branch instruction like calls, function calls, okay, or interrupts or so on, in that time, some of the data, okay, which are very useful for the present program are loaded into the stack memory, right? And we know that stack is generally, stack in ARM Cortex M4 has got a specified size of the memory is specified for the stack. We cannot grow the stack beyond that specified memory region, okay? And remember, this is very important. Stack memory is used for local variables. That means whenever you are writing a function, in that function, whichever variables are used, they are stored in the stack. So they are local variables within that function. Whereas when we talk about heap, they are used by dynamic memory allocation functions. So dynamic we can change the size of the heap according to our requirement also. You might have heard about stack overflow. Sorry, overflow. Overflow means you kept on running a program. I will show you that also, don't worry. Okay, we kept on running a program where the stack's memory size has been crossed, or that means you have overflow the stack region. So heap can be a very good example, or heap can be used to dynamically allocate a memory to manage such overflows, or it can be used for that particular type of functions. But that means heap is generated or managed only during the runtime. Okay, and there after that, when the program closes, the heap memory is almost already gone. So stack still remains there. Okay, that means stack is fixed in the memory region. Okay, CPU's current state is saved in the stack memory, right? CPU's current state is if you remember R0 to R3 and then some temporary registers. So we remember there were 8 registers, okay, which were loaded into the stack. Okay, so stack actually here covers all the related date registers which are in the CPU. Okay, so all the current state of the CPU are stored into the stack. Of course, like I said, local variables are also stored in the stack memory when we use call function and so, not the interrupt already. Okay, so it is not mandatory that only interrupt uses stack. Call, these all functions also uses stack. Whereas heap is used by the linked list and all. Okay, might be possible when we go through the course. I will show you how the heap is managed in the ARM Cortex. Okay, but that will be too deep for this course. But I will try to show you that how the heap is getting allocated and how we can change the size of heap in IAR software. And of course, like I said, it is dynamic memory location, so it can change its size also. Okay, depending. But stack is always fixed. Remember, stack is fixed memory. It cannot be changed. Whereas heap is a dynamic memory. It can change its size also. But both of them can be used almost for managing registers, data, which are to be saved during any call or interrupt operations. I will show, if possible, I will show you this part. Otherwise, this is a bit more deep for this course. Yeah.
सर जो हीप मेमोरी है सर, ये रैम में सेव होती है या फिर कैश में?
No, look, here we are talking about embedded system. Okay, I'm not talking about the computer architecture, right? And personally speaking, I am not going into that part, because computer has got cache memory, RAM memory, and all those stuffs, right? When we are talking about embedded system, everything is within the RAM, you can say, or within the memory itself. For our case, it will be always from 0000 to FFFF, which is 4 GB of memory. We don't have separate cache memory or something. Only we have two memories. One is the RAM, or SRAM, we can call it SRAM, okay, or total memory, whatever we have. Apart from that, in the CPU there are some temporary registers, right? When you talk about cache memory and all those stuff, then you're talking about computer architecture, right? In that, the OS handles all these things. And personally speaking, I am not sure about whether the heap is managed by the cache or heap is managed by the RAM. Most probably heap is also managed by the RAM itself. Most probably. I'm not sure about that, so I cannot give a concrete answer here, because I'm not very good in computer OS related handling and all. You can ask someone who is teaching computer architecture in our college. Okay, here everything is within this particular memory, 4 GB RAM, because of course we know that temporary registers are within the CPU, right? Apart from these two, we don't have any cache memory or anything. So I'm not sure, because heap is within this memory itself. Okay, we will manage it within this memory. Okay, I will show you that also, don't worry. but I'm not sure about whether it is in cache or RAM in computer, because embedded system we don't have any cache as such, right? So I cannot give you a concrete answer. You can ask someone who is teaching computer architecture in our institute, because it will be not correct to give a wrong answer here. Anyway, let's see. Might be possible in the presentation I will get somewhere about more details about that. Okay, so there are 4 regions in our memory. Okay, the first region is our memory region, normal memory region, which holds the executable code, the code memory, you can say. Second region is the region where the global variables are stored. In general, I might be using this term flash memory most of the time. Okay, and this global variables and local variables, all the stuffs, when I will be talking about them, I'll be talking about RAM or SRAM. Okay, stack is used for static variables or local variables. Okay, this is the third memory region. Fourth region is our heap, okay, which is used to handle dynamic variables. I have to search a program where I can show you the effect of heap, actually how the heap is managed. I have examples about the stack and all, which I will be showing you, but till now I have not written any program where I can show you the effect of heap or how the heap is actually managed by the microcontroller. If possible, I will show you that. Okay. So right now we will be focusing on the first 3 regions for this course. If possible, I will come up with some examples or videos in which I will show you how the heap is actually managed. Okay. But in the software, I can show you how the heap is managed when I will be talking about IAR. Okay. So for C programming, we should know about the memories, where the memories, how the memories are actually managed. Apart from that, we should know about the instruction set of a particular microcontroller. So when we talk about the instruction set, we should go for the instruction set of our microcontroller, that is TM4 C123GH6PM. Okay, so in the data sheet, you can go and check table number 2.13. So I request you all to open that. Okay, so that you can be familiar with the data sheet. So here are the instruction sets. For example, if you can recall, these are almost same like the 8085's instructions. Of course, there will be many more instructions available here with more functionalities, but these mnemonics are almost same. Add with carry, add. Okay, and which are the flags which are getting affected after this, and logical and arithmetic right shift. Okay, I will be talking about arithmetic and logical shifting, because this is an important concept. Arithmetic shifting and logical shifting. Okay, so these are almost same. Okay, but remember, we will not be writing program in this particular assembly coding. There are many courses in which they fully go through the assembly coding in ARM, but we are not going to follow that because it will be very tedious to write programs in assembly coding. But of course, if you are interested, you can use this instruction set, write simple programs and check what these instructions are doing, because they are almost same to that of 8085. Okay, and always remember, the variable or the values move from right to left, not from left to right. Just like move A comma B, where the value of B is loaded to A. Similarly, here if we are saying MUL RD, then it will be destination register, and then RN and RM. So RM and RN will be multiplied, and that will be stored in RD. Okay, and similarly, if you have add, for example, where is the add? Okay, here. So most of the time you will see that we have 3 operands in most of the ARM Cortex M4 instruction set. There are 3 operands. Otherwise, you can use even 2 operands also, but most of the time you will find there are 3 operands. The operation will be performed in rightmost 2 variable operands, and the result will be stored in the third leftmost operand. Okay, for example, here in case of add, rd comma rn comma op2, operand 2. So the operand 2 and the content of rn register will be added, and the result will be stored in rd. Okay, so this is how most of the instructions are followed in ARM Cortex M4. Okay, but we will not be following this. And remember, all the compilers, when we take any compiler, those compiler use these mnemonics, or you can say assembly code, and then they convert into C program. Then they make their own functions also. So therefore, it is even possible that from compiler to compiler, your program may look different. Okay, please try to understand this. That means, like for example, there are many compilers like Kyle, System Workbench, Microchip, IAR, okay, and even code blocks. So these compilers, they all are using almost same instruction sets, but they might be using a different approach to write different functions. So sometimes, if you are using, most commonly used softwares are Kyle and IAR. So if you will find that the assembly code which is generated by IAR and the assembly code which is generated by Kyle are two different codes. Okay, if you check the assembly code, you will find they are using two different assembly codes. So it is dependent on company to company. Okay. Of course, then after that we write a program. For that we need an approach which is known as algorithm, and some algorithms are faster than the other, and so on. And then of course assembler, like I said, every company uses the assembly code which is provided in the instruction set, and then they write their own function to accommodate in the assemblers. Okay, so it is not necessary that you write one program in Kyle, okay, and one program in IAR, both will have same to same assembly code. No, it is not necessary. Okay, it may change, but the program's output will be almost same. Okay. Okay, this was one important thing to be discussed, but I am not going to talk all these points because I believe most of you know about the difference between a compiler and an interpreter, which are better, which are faster, when we should prefer the compiler over the interpreter and vice versa. But still, okay, interpreter translate one statement at a time, okay, and into machine code. Compiler scans the entire program. This is one very important difference. That means they translate line by line, and here the compiler compiles the whole thing in one part. Okay, so here you can see the difference between the programs. Ruby, Python, they are all interpreters, so they will be compiling the program line by line, whereas C, C++, they are compilers. So mostly they will be compiled together, and then you will be getting the answer. So now the only thing that we have to keep an eye is which one is more efficient in terms of performance. That means the speed of the programming or debugging and all. So I think here the interpreters are faster. Compiler always generate intermediate object, hence more memory is needed. So you will be sacrificing memory when you are using compilers. They are efficient in terms of memory, so it will be taking less memory. Okay, here debugging is easy, but here debugging is relatively harder. So that is why most of the time you will see people are inclined towards such languages which are more easy to debug, which are easy to handle the memory and all, whereas in C and C++, handling memory is not that easy. We have to keep an eye on the garbage values, we have to clean them, or we have to assign values according to the variable itself or data type, whereas in most of this Python and all, it is all automatically managed by the Python language, so the user don't have to worry about those part. Okay, now This I don't want to discuss here because this was discussed in the last time when I covered this course, but I have made a different slide, okay, and I have discussed that slide in this particular lecture. So whenever we write a program, the program starts. So we write a program, and that program is generally written in C file. Then we compile it. It generates an object file. Okay, if there is any error during compilation or assembling, the error again we will have to go to start, modify the program, then again compile. So this loop will keep on repeating until unless the program is error free. Okay. Then after that you will generate an O file dot object file. Then the linker will come to play where it will use third-party libraries, okay, and functions which are there in your program, used in your program, and then they all will be linked, and they will check whether the variables have the same name or different name, libraries are working normally or they are clashing in or something like that. Okay, so linker will take place and it will handle the linking related issues. Then of course when the linking is perfect and everything is okay, then you will get dot a out file, dot o out file, which is object file, okay, executable object file, and then done. You will get binary file which can be loaded. Here the loader's job is not shown, okay, whereas in my upgraded presentation, the last I showed you, there are loaders also. Okay, so this you can correlate with the previous slide. Otherwise, this is just about C programs compilation, whereas in the previous slide I showed you all about the loader and all. Okay, so these are the files which are generated whenever you write a program, like I showed you before. .c, .layout, .depend, sometimes .cbp, .exe, .o. These are the files which are generated during one compilation of a C program. It is not just a C program. There are so many files which are generated, and we can even explore them, and we can open them and see them. I will show you when we will be working there in IAR. So please wait for that part. Okay. Basics of embedded system or embedded C. Of course, every program will contain some variables, functions, methods, routine, procedures. Okay. Okay. So this is the basic structure of a simple C program, which is generated automatically when you will open the code blocks. Okay. Here, these are the header files. Apart from that, what are the things that we can correlate with the lecture we have gone through? Hash include. That means this is one preprocessor. Okay. So program will not wait for preprocessor. It will be preprocessed before coming to the main. So these things will be preprocessed. So including .standard io.h, standard library.h, these will be preprocessed before coming to the main. Then after that, you enter the main. This is the function because you have brackets here. So it is representing a function. So every function will have this particular sign, or you can say brackets. Then in that function, you have statements which are all most of the time covered or which are enclosed within curly braces. So you have curly braces here, and this is the statement of the program. And there are so many things within the C program which I request you to please go through and focus here. For example, let me go to the code block, right? So you can see here there are many different colors used in writing a program. So when you are writing a program, okay, don't always use black and white kind of color scheme. Most of the time, most of the compilers, they will come with the default system where you will have black and white, and it is very difficult to understand the difference between the variables, the numbers, the data type, the comment and all. So in code block, you can go to settings, editor. Okay. In almost every compiler, you can find this kind of settings. Of course, you will have to explore them, how to change that. And in that, you come down and then you have syntax highlighting. And you see here, I have changed this particular setup according to my choice. Okay. So there are so many things when you are writing a program, like comment. Okay. Normal comment, active comment, comment line, documentation comment, and so on. So comment itself has got so many different varieties or variations. Okay. Then you have numbers, like here you can see 20 is a number, so this is getting the color light blue. Then after that you have inactive numbers, then keywords. Okay, so keywords, if you check here, int is a keyword, so that's why it is, I am keeping it with a different color. Okay, then you have user keyword, global classes. Please, whenever you get a time, try to get the definition of these things, or these members of any program, because the more you explore these terms, the more you will be coming closer to the C program. So for example, character, and difference between character and a number and a string. Character and a string, this is one very big, most of the time students find it very difficult to differentiate between a character and a string. Okay, in C, actually, how the character and strings are differentiated, or whether there is a difference between string and character in C or not, because these are the things you please go through. Preprocessors you can see here include files. These are preprocessors. Okay, of course, whichever starts with the hash. Okay, and then you have operators. When we talk about operators, we have plus, minus, equal to, less than, equal to, plus, plus. Okay, this kind of things. These are all operators. Increment, decrement, plus, equal to, this compound operators. Okay, so please go through them. Of course, I will be uploading the videos, but apart from that, show your curiosity on these things, because I believe most of you might be knowing it, but revisiting these terms will help you to write better embedded codes. Okay, might be possible you already know them and you have used in C programming in your previous courses, but that might not be the same case here when we are talking about embedded C, because here things have to be managed in a different way. Okay, so I'll be making almost all the videos related to these terms, and I'll be discussing some of the important terms in the course also. For example, defining variables, arithmetic operations, expressions, plus, minus, into, divide, and all, modulus. I have created one video on this, on variables also. Pointers, most probably we will be discussing today, otherwise I will be loading the video. Mathematical operators, I have loaded in the YouTube. Bitwise addition, preprocessors, and wherever you find a better video, it is not necessary that you always go through my video. Wherever you get more elaborated, more better explanation, follow them. Aligned, unaligned data, I have discussed that part. Okay. ISO C99. How many of you know this term, ISO C99? Have you heard of ISO C99? Anyone? किसी ने सुना ISO C99? शेयर करो अपना एक्सपीरियंस अगर किसी ने सुना है तो. ISO C99. कोई बोलना चाहता है कुछ? Anyone?
सर प्रीवियस सी लैंग्वेज का नाम है.
नहीं, this is the, I think this is latest. Okay, there are many versions of C. So this is one of the standards, ISO C99. I will show you that. Okay, ISO C99 is one of the standards, and of course there is Misra C and all. So we must be aware of these standards, when they came, why they came, what were the changes that they made in C programming. Okay, And of course, arithmetic and logical shifting, standard data types which are allowed in C, arrays, bitwise shifting. All this will be used in writing programs for our course. Okay, these are the major topics. Other than that, there are many other topics in C which I might not be able to cover all those topics because of the limited time in our course. But if you have any doubt, you can definitely ask me. I will try to answer them. Okay. Okay. So first of all, let us see about variables. I have discussed this in my video. Okay. In C, one important thing that we must remember that all variables must be declared before they are used. For example, you cannot directly write A equal to B plus C. Okay, where you have defined B equal to int B equal to 20, okay, comma C equal to 10. You have declared this, but you have not declared A, or you have not defined the data type of A, therefore you cannot directly use it. So before using any particular variable, you must declare it. Declaring a variable means you must define the data type. So there are two things to remember, int A, and there is a difference between int A and int A equal to 10. So this is declaration, you can say. This is just declaration. Okay, whereas this particular line is declaration and initialization. Okay, so in C, always prefer to go with this until unless you have some other plans in your program. Always try to initialize it. Otherwise, there might be some garbage value always present in the variable A. I have showed you that also. If not, I will cover that. Okay, let us. If you want, I can show you. Just it will take 1 minute to cover this part. Okay, I will just save this and disable both. Okay, creating a new file. We'll go for empty file, this one, and then just test. Okay, test variables. Okay, debug and release mode. Okay, both. Let me take the code from the. Oh, what a mistake. Okay, I will take the code from. Okay, I will write the code. Don't worry. Hash include. So these are my preprocessors, and I define the main function here. I will start the statement here. Before that, let me return Control J, return 0. Done. Now I will define a variable int A. Okay, and then I will define another variable int B is equal to 10. So now here, this part is just declaration. Okay, this is. Now I will just put a comment here. Here, declaring a variable A. Okay, done. And in the second line, we are not only declaring and initializing the variable B. Initializing. Okay, something wrong here. I missing. Okay, so done. Here there is a difference between these two instructions. Let us see that. So I will just compile it. What happened? A double hash. Okay, gone. Okay, done. Okay, they are not used, so there is 0 error, 2 warnings, because we are not using these two variables. Okay, we are just declaring them. I always told you to use step-by-step debugging. So I believe most of you are familiar with these windows: watch window, memory window. If you are not, then let me just show you. While debugging, you can go to debug windows, use watches, Then debug windows, you can go to debug window and disassembly memory. Okay, I'm going for the memory. So these two are there. So now here you might have checked one thing, that when we declared this, or when we are debugging this program, automatically the program came to this line. So this line has been already executed. So if you have only declaration, it will be executed automatically. But when you are assigning a value or initializing a value, the program will wait for you. Now I can go and execute next line. Now here you can see B is 10. Okay, let me show you one more time. Okay, build the program, step into next line. So, okay, now right now you can see here in the B, there is a value 41944432, which is already present, which is a garbage value because we have not assigned any value to the integer B right now. And we don't know what is there in the A also. In that case, you can just go here and type A, enter. So optimized output, or it is not showing any value because it has not been assigned any value or initialized the value. So this we have to keep an eye, because it is possible that you might be using B in the next line without initializing, and it will use this garbage value to produce the result. Okay, so always initialize the variable. So next line, and you can see B is now initialized with the value 10. Before executing this line, B was having a garbage value. Done. This is about variable declaration and defining and declaration. Okay, so wait a second, where is the, no, okay, this was done. I hope you can see my screen. Okay, so prefer to use this particular line, this kind of declarations, X comma Y comma Z in one go, rather than using 3 or 4 lines. Okay, because it will just increase the space of your program. Okay, done. Next, standard data types in C. There are some standard data types which are available in C, like char, short, long, int, float, double. Okay, and they generally have specified values. For until unless you reach to the int, almost the previous variables like char, short, they have their own size which are very clearly defined. Char will be always 8-bit. Whether you use C, C++, Java, whichever language you are preferring, most of the time you will find char is always 8-bit. And here you can see minus 128 to 127. So char is 8-bit. Okay, 8-bit. That means it can take a value between 2 to the power 8. Okay, so which is 256. So here it is showing, it is all automatically defined that this is a signed number for signed numbers. Okay, so in that case, minus 128, and there will be 0 in between, and then 127. So this is defined. It is signed number. But when you will use unsigned, you can range from 0 to 255, which is the most cases you will find in Arduino Uno. You might have used this kind of values between 0 to 255, 0 to 1023 and all. Okay, those are unsigned numbers. Now, like I said, integer, it is not clearly defined. It may vary from processor to processor or number of bits. So therefore, it became a very big issue for the programmers who are actually working on hardware. Because of course, whenever you are writing a program, be it an operating system itself or any other compiler or any other software or a video game, you name it, any software. Whenever you are writing a program, you have to keep an eye on the size of the memory or size of the microcontroller. And it become a very big headache for the programmers, because one version of the program will not work in the another computer. So if you have written a program for 32-bit system, okay, that was not working with a 64-bit system, and it was not even working with 16-bit system. Okay, so it was not working. So this became a very big headache. So you will have to write program for processor to processor. So in general, C only follows one particular rule in such cases, in this kind of cases. That is, short and int will be greater than 16-bit and long will be greater than 32-bit. But remember, short will be always smaller than int and int will be smaller than long. So it will be like this: long will be always greater than the size of, okay, size of long will be greater than size of, size of int, and it will be always greater than size of short, okay, and it will be always greater than size of int, char. So only this is defined, but here in this region becomes very difficult to manage these things, because int is, the size is not defined. Only this relationship is defined, but the actual size is not defined. So that become a very big headache. So for that, okay, okay, I will come to that. Okay, for that ISO 99 C99 came up with solutions. I will show you that part also. For that, this is done. Okay, we're defining variables. I told you variables can contain alphanumeric values. Underscores are allowed. You cannot start with directly a number. There is a video, separate video I have posted in my YouTube. Please go through that. Okay, I defined it very in-depth video I have created for this, where defining variables and all. So green ones are allowed and red ones are not allowed. So why? For example, int, okay, this is correct, and using underscore is okay, no issues in that. But using spaces between the variable names are not allowed. For example, int 2 space lines, it is not allowed. First, why it is not allowed? You are starting with a digit, it is not allowed. Second, you are using a space in between two alphabets or two characters, it is also not allowed. Underscore x, it is allowed, because underscore is allowed in C. Int while, int float, these are not allowed because you are using keywords. Okay, these are all keywords. I believe you all know this basic fundamentals. Okay, so using keywords in declaring a variable name is not allowed. So these are all the basic fundamentals of C defining variables. Apart from that, I have also discussed about formatted output. We call it data specifier or format identifier. So you can use this kind of, okay, data specifiers to specify the way you want to print or to represent a number. For example, we were writing a program here, right? This one, okay, and I can write here print, okay, print. Okay, here I can write the value of variable b is, okay, percentage I, okay, slash n here, okay, comma b, okay, and home control, sorry, control z, home control c. Okay, so I can write here control, instead of using percentage I can use percentage x also. What does that mean? Percentage x means, from here this table you can see percentage I, percentage d, they are used for signed decimal notation, but there is a difference between these two also. I'm not going into that depth. Okay, percentage x is used to represent hexadecimal numbers, whereas percentage I are used to represent integers, or you can say decimal numbers. So let us check the console and try to understand this concept here. So okay, done. So let me just run the program. Okay, so next line, next line, next line. So in the console you can see here there is a representation. There are two different ways to represent the same data which is there in the register B. or the variable b. So here in the first line it says the value of variable b is 10. Why? Because it is represented by percentage I, which is an integer. Okay. Okay, done. Whereas in case of what happened? Console. Okay. Whereas in case of second statement, the value of variable b is a. Why it is a? Because 10 is converted into hexadecimal and it is represented in a. So it is your choice to change the data specifier when you are writing a C program. Okay, so you can convert one data type to another data type to represent something. So this is what is all about data specifiers. So please keep an eye on this table. You can use this table and use for specifying different types of data specifiers if you need in future. Done. There are many escape sequences like I showed you here in our program, this previous program. We were using /n, which means next line. Okay, so yes, escape means enter, the button enter in our keyboard. Those are all escape lines. So similarly, apart from that, there are many other ways to escape, which is %n, which is very commonly used, print to new line, %b, backspace, tab, /, print, double quote. I have a program here, but I don't want to cover them right now. Okay, so you can just check here. These are all different types of data specifiers. 2D, that means 2 spaces will be added before printing this value of b. 5 spaces will be used before printing the value of b, so on. Okay, and here, for example, 15.3 is there. Okay, let me just show you if needed. Test1.c. This is test1.c. Okay, let me just close all the rest of the windows. Which is this one? Disable. Please, if you have doubt, do ask me, because might be possible I'm going a bit fast. Okay, this is enabled or not? Yeah. So I will just compile this part. So build log. What happened? Okay. Okay. No errors. No issues. We can go through this program. So we have declared, or we have used 2 preprocessors. We are using standard IO, standard lib. Okay, standard lib. Okay, I will come to the standard lib. Okay, remember, this library file is what is important for when you correlate with ISO C99 version. Okay, ISO C99. Okay, so here we have the program, and let us debug it line by line. So here you can see on the right side, the watch window, all the variables are there. A, B, C, D, E. This is what we declared in our, okay. Okay, so A, B, C, D, E, F, these are all the variables which are there present in the program. Done. So because here the variables were only declared, they were declared without waiting for the program. So these all have been executed. Done. So A, B are integer type, C and D are floating type, E and F are also floating type. Okay, float variables. Now A is getting 15. So right now A is 4194432, which is a garbage value. So A is 15 now. Done. Next, B is A by 2. So remember, B is an integer. So 15 by 2 will not be a round number, or you can say a real number. It will be the floating number, but still you see 7, whereas actual number is 7.5. Why it is 7? Because B is an integer. It cannot show you floating numbers. if you want to represent them, or if you are using data specifiers to print that values, 1, 2, 3, I have executed the 3 lines, and you can see here %d without any space, you have printed the value 7. Okay. Now here you can see one space, extra space is used. In the second place, you have written the value of b. If you are using 0, 5, that means 5 spaces are used to print the value of b. So 4 values are 0 and fifth value is b itself. Okay. So 5 spaces have been used, simply speaking. Now, this is how rest of the program will run. So C is 15.3 and D. Now C is a floating variable, a floating type. So it can hold 15.3. But in the watch window, you can see it is storing 15.30000002. Anyone why it is storing this number? Why it is not storing 15.300000 something? Why this 2, extra 2? Anyone? Why C is not storing 15.3 only? Why it is storing 15.30000002? Anyone? Is there anyone in the class or not?
Yes, sir.
Yes, sir.
Okay, Kunal, can you tell me why C is 15.3000 after so many zeros you have 2? Why it is not storing 15.3 directly? Anyone
Sir,
else?
because sir, the length of floating point number.
No, but in that case you can put extra 0 there, na? It will fit the length.
Yes, sir.
Then why 2? Anyone else? Anyone else? So you guys never had any doubt, na? Sajal Pathak, why it is 15.3 dot something 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 2? Sajal.
So no idea.
No idea. Anyone having any idea about this? Why it is not printing 15.300000 something?
So because the float never stores the exact value as it is done by a different ALU.
No, not different ALU, no. You cannot say it is done by different ALU.
By floating point unit, I mean.
Yeah, you are using floating point unit. And when you are using a floating point unit, either you will be using single precision or double precision, depending on the core of your microprocessor of your system. So my system is a 64-bit processor. Definitely it will be using floating numbers which are 64-bit. So it will be using double precision values. But in every conversion between the float numbers, you will find some error. I told you in the past also when we were discussing single digit and double digit or double precision floating values. I told you that there will be some error, and that is this error which is represented here. Okay, so please remember these things. These are not just simple 15.3 means it will store 15.3. No, it is, we have to check whether it is using single precision or double precision floating numbers. So anyway, you can see what you can see what is this program. Okay, you can go through this and you can check all the outputs here.
Excuse me, sir.
Mm-hmm.
सर परसेंटेज 05D में 40 पहले क्यों आया, मतलब वो प्रीफिक्स क्यों आया?
This one.
Yes, sir.
Because you has put a space here. You have written that before printing this percentage D means the number you have to print. You are telling the system that you have to write that number spaces. Understood?
Okay.
Instead of D, for example, if I write B, okay. For example, if I write stop the so there are so many things to explore. Okay, remember. So if I write just here 150. So now it is a 3-digit, taking 3 digits, right? So, but still you are telling the system that print this value of b in 5 spaces. So let us check again. Please keep on exploring this kind of things by varying the program in on all possible values. You see here now what is printed here? 150, but using 5 spaces. Got it?
Yes sir, yes sir.
So,
सर तो ये गार्बेज वैल्यू हुई क्या जो 2 0 शुरुआत में थे?
no, they are not garbage value. We are forcing the system to write it. Understood? Of course, this is not garbage value. We are telling the system to use 5 values. Okay, if even if I remove the 0, it will still print the same. If I let me check, 0 removed.
तो zeros नहीं आएंगे मतलब उसमें फिर?
No, still zeros will be printed. Let us check. So please clarify all these things, because you have the no, okay, 0 is not printed. Yeah, it is using space, but zeros are not printed. So please cross check all these kind of features which are there in C. Okay, for example, here it will represent the number into 5 places only. In general, for example, let me show you here. In general, okay, now go down, down, down. Okay, you see here, in general, whenever you are printing a floating value, it goes up to 6 digits. It always prints up to 6 digit, but you can limit that decimal number or decimal places also. Here, for example, 3.2, it says print up to 2 spaces, 2 decimal places. Okay, here you are saying up to 5 decimal places. 5 decimal places. And here one more thing is that there is 0 dot something. So you can preside with 0 if you are going for a large number. For example, if you write 06 here, what will be there? Now let us check. If I just write 06 dot, these are the things which are there in C. Okay, so you can manage the memory in so many different ways. Let me check here. Okay, now you no, so this particular number does not have any effect on floating number. So you keep on checking these things. Okay, done. Although they are not that important, but still it is all about how the memory is managed by a variable. Similarly, I told you about D, F, E, exponential numbers, G. I have discussed all this in my YouTube channel. So please go through that. Okay, here we don't have to discuss all this C programming related things. Try to follow these 3 works. Okay, write a C program. Okay, to in this, just print this thing in C, comma, lowercase letters are significant. That means C is a case sensitive language. So just you have to print it. So printf double quotes, you can just print write this number. Secondly, print the following. Main is where program is executed. So this is your program to be written. Printf, within the printf double quotes, you can write these things. So it is not that difficult. How many of you can find errors in this particular program? Let us check. Tell me, what are the errors in this program? How many errors are there? First, you take some 2 minutes and come up with a number. Are there any 15 error, or are there 20 error, or 5 error? Take your time. Tell me how many errors are there in this program. Or you can just type it in your code block, and you can find the errors in that also. We can wait for 2 minutes. Just 24 by 26. You can answer. By that time, if anyone have any doubt, they can ask the doubt also. Anyone having any doubt? No doubts. Still, you don't have any doubts. Good. Almost.
So, why does the garbage value occur in the C program?
I don't know. I don't know, because might be possible this is the way the C is written. C program is written. It always takes. Okay. What I can correlate with C program is that whenever we declare a variable, right? What is the meaning of declaring a variable? For example, we are declaring a variable. For that, we at least should have one data type, then a name of the variable. Okay, for example, var, and then if suppose you are not initializing it, so this is the minimum thing that you need to declare a variable, right? These are the two things. You cannot declare a variable without data type and without a name, right? So whenever we declare a variable in the memory, what is happening in the memory? So first thing is that every variable will be allocated some memory. For example, 0x000, suppose 005. Okay, assume this is the location which is allotted to variable var. Right? In that, right now, this is what is this particular part in the memory? This is representing what? What will be here inside this thing? What is this part? This part. How we call that? This is, you have the address here. Okay. Apart from that, what is this particular region called? Anyone? Register. Right? Who was asking this question? Please respond.
Yes, sir.
Right.
Yes,
This
sir.
is a register. What is register then? What is register? This is one register. It is
Memory.
Storage.
storage or memory. This is memory. This whole thing is memory. What is register? If suppose someone asks you what is the precise definition of a register?
Made of flip-flops.
No, you can say it is a collection of flip-flops. Okay, or otherwise you can say an array, more precise, right? Array of flip-flops. Perfect. What is flip-flop? What is flip-flop? Flip-flop is a digital device, right? It is a digital device. And digital device, what can be there in the digital device? It can be 0 or 1. So by default, when you are just declaring this part, you are not initializing it. Of course, some of the flip-flop will be 1, some will be 0, some will be 1, some will be 0, something like that. It is not necessary that always the memory will be 0, 0, 0, 0 all the time. No, there might be some data previously used or previously entered in that memory region. So this is what you see when you declare a variable that we call garbage. This is garbage. Why? All the flip-flops might not be always 0. This is called garbage. Okay, garbage values. Now, can you tell me what happens when you delete a file from your computer? When you delete a file from your computer, what happens? Suppose there is a song in your computer which takes this much of memory. This is all taken by the song. Of course, song will take some memory, right? The song is written in the memory. What happens when you delete the song? Anyone?
So the pointer pointing to the song resets.
The address of the song is deleted, or it is not allotted, or it is cleared. That is why when we use data retrieving softwares, we can retrieve the song back. Only the address is gone. So if you don't know the starting address, of course the song cannot be played. So in this region, the song is still there. So what is the song here now? Song is the garbage. Understood? the person who was asking the doubt, do you understand what I am saying here?
Yes, sir. Yes, sir.
So whenever the memory is allotted, might be possible the flip-flops are not always 0. So some of them will be 0, some of them will be 1. And this register, of course, that zeros and ones will make a number. And that is garbage, which is allotted to this variable, unfortunately. Anyway, this is why in C you have garbage values. In another languages, of course, whenever they allot a memory, they might be able to clear that memory beforehand. How many errors are there? Anyone? 5, 10, 15, 6, 8 errors. I will be ending the lecture here. How many errors are there?
5, sir.
5.
5.
6, sir.
Let's check. 1, 2, 3, 4, 5, 6, 7 errors are there. Okay. You got the answer?
Yes, sir.
Capital V is not allowed, right?
V.
Capital int is not allowed.
Initialization.
This is not
Curly
allowed.
braces.
So you, right? So some of you might have missed 1 or 2, but keep an eye. These are the things we have to practice. So make your own small C programs and go through that. Okay. Done. I am going to end the lecture, and next class we'll be going through the arrays and all, and then we'll be starting to go through the IAR also. So please install IAR beforehand. Okay. If you have any issues in that, then please send me a mail, or you can post in your classroom. Okay. Thank you.